Hey everybody, the purpose of this video is to get you some instructions on how to use the binomial distribution function in Excel. This is going to help y'all who don't have a TI. Actually, this is probably better than a TI in all honesty, just because of its power and its graphical interface. But regardless, this will give you another tool in case you want to use something besides the handhelds. So I'll start with the example we used in class, which was my chicken flock. You've got 4 girls, so I'm going to put down what we know up here. We know the probability of a female pullet is 0.9, so we know that. Or not 0.8, 0.9. Okay, so 90% of them are female. Okay, that means the chance that you got boy is 0.1, but the cool thing about the binomial is you don't need to tell it that. It can do the subtraction automatically. So what I'm going to do is let's create the distribution that program I gave you guys in class does. So x equals the number of females that we end up getting out of a certain flock. All right. And then here we'll put the probability of that number of females. I'll center these. So in class, the last one we did was 4. We wanted to buy 4 chicks or 4 pullets. Okay. So the idea, this is all you need to know. You need to know that you're buying 4 chicks. It's a fixed number. Independently, there's 90% of the population is female. So if you buy 4 of them, okay, you might not have any girls. You may have 1, you might have 2, you might have 3, and you might have 4. So those are your options as far as how many girls you might get in your draw there. So now the interesting part is how do you get Excel to basically run the functions that we did in class? And this is pretty awesome because I mean, we did it in class. It took us a while. We definitely schlepped through it, and it was fun. I mean, it was fun at first, but it got tedious towards the end. So, as it turns out, there's a beautiful, beautiful little function. So, just start over here in the first probability. You go equals binom. So, I start typing binom for binomial, and there's lots and lots of different choices. The first one's the one we're going to use, binom.dist. So, you can double-click on that one. And the first thing it asks you for is it asks you for a series of prompts. So it needs to know what numbers to use to calculate the probabilities. Essentially, they're the same ones that you guys used in class when you calculated them. And I'll show you that in a second too. So the first is number S. This is Excel ease for what number of females are you interested in. So you're going to go over here. I just go over here and click F7 because that's the cell I want to use. I want 0 females, comma, out of how many trials? Well, out of 4 trials, comma, what's the probability of a female? The probability of female is 0.9, comma, and then it asks for cumulative. Now, this is one thing that you might not know about Excel. If you arrow over any of these commands and click on them, ooh, I could be wrong. I thought they told you something about that. That's okay. Cumulative, you just want to put 0. That means don't make it cumulative. Cumulative would mean it would give you not only that probability, but also down. So I'm going to close off the parentheses, press enter, and it tells you 1e negative 04, which is 10 to the negative 4th power, which is 0.0001. Now remember, I'll add a little column here, px. And I'll put ... in class. We did this in class by doing 0.1 to the 4th power, which comes up with the exact same thing. It just in this particular case, it gives it to you as a decimal. Cool? Now, what's rad about this is since you made the number of females in F7 a variable, you can drag the formula down like that. And it's going to fill in all of the probabilities you need. You can check it at the bottom. The sum of those is going to sum to 1. Beautiful. So you know it works. And this saves you all the trouble like we did in class. Over here, when we had 1 female, for example, we had to do equals 0.9 for the 1 girl. And then we had to do times, what was it, 0.1 cubed. And then we said, wait a minute, we're off because we had to actually multiply that one by 4. Because we had to deal with where is the girl. And you can see what this binomial function does for you is it really does give you a nice quick tool to generate these distributions. I can delete this column now. Delete the sum 2. And then what's also rad, I gave you another program for your TIs. Whoops. Started up Camtasia. I apologize. I gave you another program for your TIs that graphed the distribution. I called it dist draw, but what's so nice about this is you can simply select these and then insert any type of chart that you want. So I just real quick inserted a bar chart, and there it is right there. It's not great. I mean, you need to touch it up a little bit, but if you needed a chart, you can definitely get in here and do that. And anybody that needs help setting these things up, I'd be more than happy to help you set up these things. As a matter of fact, let's run another example, and we'll do one in here. So let's delete that. So the real power of this is it's constantly updatable. So you can get in there and mess with it and update the variables. So what I like about it, let's do another chicken flock. Let's do a larger flock, and then we'll actually make a plot on that larger flock, and we'll see the real power of it. So that's basically, you're done. After a 6-minute video, you understand how to use the binomial distribution function. What I'd like to do now is teach you guys a couple other things that are kind of rad about Excel. At the same time, analyzing something like this. Like, let's suppose we instead of having 4 chickens, let's say our flock size is 30 chickens. Okay, I think somebody in class actually had this flock size. And let's say the probability of a female pullet. Now watch what I'm going to do. I'm going to put this over here, and there's a reason for that. There's a reason I'm going to do that. And let's rebuild this distribution now. So 0, 1, 2, 3. Now watch this. Once you get Excel started on a numerical pattern, 0, 1, 2, 3, you can drag that bad boy down, and it's going to continue making that pattern as far down as you want it to go. So right there, it continued that pattern all the way down to 30. Can you see that right there? Now, if you were to inadvertently grab this and pull it down, you're going to start getting nonsensical results, because that formula that you typed in right here is assuming a flock size of 4. So you can see that after 4, it gives you this goofy error, number error, because it's trying to calculate something that's impossible. But that's what's cool about this is you can actually use these numbers up here to rewrite this formula. Let me show you what I'm talking about. Okay, so for example, in this function, you definitely want the number in F7 to be the number of girls that you get out of 30, for sure. But the flock size of 4, you don't want to be 4, you want it to be 30. So I'm going to go ahead and just click on that right there. Okay, and I'm going to come back to that in a second. 0.9 is the probability of a female. I'm going to click on that right there. Good so far? And then I'm going to leave it at 0 because I don't want it cumulative. I'm going to press enter. All right, 1e negative 30 for 0 females. Hopefully that makes perfect sense. If they're 90% of your flock, or if 90% of pullets are female, you should not be getting all males. Now you got to be careful with this. Here's Excel trick number 1. If you try to pull this function down to 30, you're going to start getting these weird, nonsensical values. And the reason for that is when you pulled it down, it made all of those variables what are called relative references. That F8, you did want it to go to F8. You did want that, but you didn't want 90% to get shifted down to G5 there. Or excuse me, you didn't want 30 to shift down to this cell here. So what you need to actually do back in the original cell is change G4 to what's called an absolute reference. And the easiest way to do this is to simply press the F4, highlight it and press the F4 button. And do the same thing with G3. Now when you do that, it doesn't change the value of that cell, but when you drag that bad boy down, it's going to update all of the individual values. It's going to keep, if you click on any one of these, like for 11, F18 became, relative, which means as you drag the formula down, each additional cell you go down updates with the number of chickens. And this is 15, 16, 17, and so forth. But notice how G4 and G3 are staying right there. And that's really what you want. You do want that, right? You want to be able to calculate those based on these fixed values up here. Good so far? All right. Now, one thing I didn't mention before about this is the average of this distribution. On average, what would you expect? You kind of have to use the definition of the average of a discrete probability distribution here. So you're actually going to have to create the column x times p of x. Now there is a function called sum product. I don't want to teach you that right now. So I'm just going to show you how we did it in class. You take each data point and multiply it by its probability. And then you sum that bad boy, or you drag that bad boy all the way down. And then you sum that column. This is essentially what we did for about a week in Math 243. Notice that the average is 27. And hopefully that makes perfect sense, because in the binomial, the average is equal to the sample size times the probability of success. So you got 30 times 0.9 is definitely 27. But you can always run one var stats on a TI. You just can't always run one var stats on an Excel spreadsheet. So if you wanted to find the average, I'm going to color that gray. If you wanted to find an average, you could totally just run you can do it like we did in class, essentially, is what I'm getting at. So that's one thing you can do. Now, if you wanted to, this is what's kind of cool about this. I'm going to minimize it a little bit. You can then analyze what happens to the flock if the probability changes. Now, before I do that, I'm going to make a real quick graph of this. I'm going to select these values. I'm going to go to Insert, Column. I'm going to drop this bad boy in. Now, Excel's silly. When it does this, it doesn't know that I actually want to have this on the horizontal and this on the vertical. So for some reason, it plots everything as bars. So I'm going to left click on the x equals number of females, press delete. There's the actual distribution of the probabilities. So this is actually, I'm going to give it a good title, probability distribution for pullets. Distribution, I should probably spell it right, huh? Distribution for pullets. I'm going to give it an axis title here under layout, axis title, primary, vertical. Let's make it horizontal. Okay, this is the probability of, spell that right, probability of X pullets. Okay. And then here, down here, I'm going to give it a title as well, axis title, horizontal, below axis. This is actually the number of pullets. All right. Oh, you know what? This is not. This is probability of X girls out of 30 pullets. That's a better way of phrasing, because that's actually correct. And this is the number of pullets purchased. There we go. So in other words, if you bought, oh, this is wrong. That shouldn't be 1. That shouldn't be 31. This is something else that Excel's kind of silly. It calls this the first element, even though it's 0. So here's a quick fix for that one. You can go into this. I'm going to right-click on it, select data. I'm giving you a lot of Excel pointers here. We're going to edit this, and we're going to select this label range here. There we go. Now it makes sense. Now we're going 0 to 30. I don't like that. I'm going to delete it. So there's your distribution. Notice how the lion's share of what happens is over here. That should make sense. If 90% of your birds are female, you should have the lion's share over here. Now what's cool about having this graph is you are able now to mess with the probability. I was very much questioning that 90% that the guy said. So I asked him, how sure are you about that? And he said, I'm totally sure. I'm like, okay, I trust you. But what's cool about this is you can now mess with it. You can change that cell to 85%. And when you do that, you see how the actual set of the graph changes. It shifts down a little bit. Because now the average number of pullets is 85% of 30. No longer 90% of 30. It's 85% of 30. Or even 80%. It's going to shift down again. This is why I wouldn't let my wife purchase, or not purchase, but bring home pullets from, or chicks from Lava Ridge. When they're unsexed, you're at 50-50, and then you get a perfect bell curve, which is directly centered over 15, which hopefully makes sense, because if, in an ideal world, if they're 50-50, half of them are going to be boys and half of them are going to be girls. Well, if we want eggs, we don't want boys. Ideally, I'd like this probability of a female pullet to be as high as possible, like 0.99, so the graph looks like that. But the only number I ever get from the breeders is 0.9. So I mean that brings us back to our original graph of 0.9. But what's cool about this is you're able to get in there and fluctuate that. And there's all kinds of other cool Excel tricks you can do. You can make a slider to adjust this probability, and you can, if you want to, you can get in here and you can edit these bars. Some people don't like these bars when they're gapped, so you can make it no gap, and then you've got a nice smooth bar, and then you can really format the data series by adding the borders to it, and then you can make the borders. I mean, you can have a lot of fun in this one. It's it's much better than your TI because it's able to get you a lot of other options that your TI doesn't have. So here's a quick, like I said, a quick introduction. Hopefully it was helpful, and yeah, we'll catch you guys in class.